Hello, so I just wanted to give another example on adding fractions with algebraic terms involved. So firstly, just to revise how we add fractions in the usual sense, so say we have something like 3/4 plus 7/9. Now we can't add these two fractions because the denominators are different. So the denominators essentially determine sort of the size of these pieces, if we think about it. So we can't add the 3 plus 7 because we're adding things of different sizes. So what we first need to do is change these into a common denominator. We do that by finding a common multiple of these two numbers. Now we can always find a common multiple by multiplying the two numbers. So in this case, we change the denominators into 36s because 4 times 9 is 36. Now, with the first fraction, because I multiplied the bottom by 9 to get 36, in order to keep that fraction equivalent, I need to multiply this top number by 9 as well. So I get 27 on 36. For the next fraction that I'm adding, because I multiplied, again, I'm going over 36, because I've multiplied the 9 by 4 in this case, I also need to multiply the top by 4. So 7 times 4 equals 28. So now I've got the two fractions, they've got the same denominator. I can just add the top two numbers to give me 55, and then 55 on 36, and I can simplify this fraction if I want to, or just leave it as it is. So when it comes to algebraic terms, we essentially do exactly the same thing. So I've got a 3x on x plus 2, then I'm adding a y plus x on xy. Now again, we have two different denominators, so I can't add these two fractions together. In order to define a common denominator, I do exactly the same thing as I did before. I want to multiply these two numbers together. So my denominator is going to be x plus 2 multiplied by xy, which I can do as xy times x plus 2, or either way around. So this is my common denominator that I'm going to use. Again, looking for an equivalent fraction of this first term. Since I multiplied the bottom by xy, I need to multiply the top by xy in order to keep the fraction equivalent. So I'm going to have 3x times xy, which gives me 3x squared y. Because I have 3 times x times y. So 3x squared y, so 3x squared y on the top here. Again, still going to have the xy on x plus 2 here. Now, because in this case, for this fraction here, I've multiplied the bottom now by x plus 2, I need to multiply the top by x plus 2. So I'm going to have y plus x multiplying, remember to include the brackets, multiplying x plus 2. And so this fraction here is equivalent to this fraction, it's just multiplied through by xy, and this fraction here is equivalent to this fraction, it's just multiplied through by x plus 2. And now because I have them over a common denominator, I can express them over that denominator, so xy, x plus 2 here. And on the top I'm going to have 3x squared y. I can expand this out because then maybe after I expand it I might have some terms that I can add together. So I get plus, expanding out, I go y times x gives me xy, and then x times x, so that's plus x squared, and then y times 2 gives me 2y, and then x times 2 gives me 2x. And actually here I don't really get too much that I can expand out. I can't cancel out this xy here with, say, this xy, or with the x and y that's present here, because I don't have xy in these terms as well. So this is probably okay to leave the fraction in that form. Okay.